Hello, in this video, we're going to talk about transition state theory. To understand this, we have to look at the energy profile diagrams, and so let's have a look at the exothermic reactions diagram first. As you can see, for exothermic reactions, you have the reactants molecules. When they are colliding with one another effectively, they will be able to form the products. But before this is going to happen, what happened at the area over here on the activation energy, this is what we call as the transition state. So the reaction will go through a transition state first before they will be able to form the products. The same thing will happen for endothermic reactions. You have your molecules for the reactants colliding with one another effectively, and when they have enough energy to overcome the activation energy, they will reach to that point over here to form the activated complex before they will be converted into products. And remember, the area that we have over here, this is what we call as the transition state. So, transition state is defined as the configuration of the reacting molecules. Okay, so you have the reacting molecules over here. So we're just going to take the examples of endothermic reactions. Same goes to the exothermic reactions. You have the reacting molecules, and they will be forming a configuration on the transition states, which is the activated complex. So transition states is the configuration of reacting molecules during a successful collision before product is formed. So before the reacting molecules, when they reach to the product stage, what happened over here, they will go to the transition state first, okay? And then as you can see just now in the energy profile diagram, they will be forming activated complex at the transition state. So activated complex is formed. So basically, we have three characteristics of the activated complex. So the first one that we need to look at is potential energy. So the activated complex will have potential energy higher than the reactants and the products, okay? So they have higher potential energy than reactants and products. And that is shown right here. When you look at the activated complex, it is at a much higher potential energy if you compare with your reactants and your products. It is the same for exothermic as well. When you look at your activated complex, it is at a much higher potential energy if you compare with your reactants right here and the products right there. Okay, and then what about stability? So for stability, it's going to be slightly different now. Okay, for the stability, activated complex, it is very unstable. And thus, it has short half-life. Okay, so activated complex is very unstable. It has a short half-life. And what about the chemical equilibrium? The activated complex and the reactants, they will exist at chemical equilibrium. Therefore, the activated complex and reactants are in chemical equilibrium. Okay, so these are the three characteristics for activated complex. So we have the three characteristics of activated complex.